Hey guys, welcome to CodeChef's YouTube channel. The problem that we are going to discuss today is Chef Up. The problem appeared in October Cook-Off and is a difficulty level of easy. There are no prerequisites to solve this problem. The problem statement goes as follows. Chef is a wanted criminal and N police officers are up for catching him. So it is given that the officers want to catch Chef no matter what, and also Chef wants to eliminate as much as officers as possible, preferably everyone, before getting caught. Okay, so neither the officers nor Chef will run away before accomplishing their goals. So this is the story, and now the question goes as follows. Chef and the officers are standing on a one-dimensional grid, and the coordinates of this grid range from minus 10 to the power 10 to 10 to the power 10. So the grid is a one-dimensional one, and it is quite long. That is, the integer points are from minus 10 to the power 10 to 10 to the power 10. And Chef is initially standing at coordinate C. So you can imagine it as follows. There is some straight grid, and the extremes are minus 10 to the power 10 and 10 to the power 10. Chef is standing at some point C, and the ith officer is initially at coordinate Pi. So there are n police officers, right? So there will be coordinates P1, P2, P3 all the way up to Pn. So they are also present on this grid only, but on different positions. Okay, that is, all have a distinct position. Why distinct position? Because it is given in the question that all the coordinates initially given are unique. It means that no police officer's coordinate is matching with C. Okay, so that is given to us. After that, the officers and the chef then take turns to move. Okay, so each time, after like every second, they make some move. Okay, officers as well as the chef. So how are the moves? That is also given. So first of all, the officer team moves first. Okay, that is also given. So during their turn, all the officers, they simultaneously move to an adjacent cell, such that at the end of the moving process, no officers are on the same cell as chef. So they can move to their adjacent cell, but they should not land on the cell where chef is present. Okay. Also, the officers cannot also land on the same cell. That is, two officers cannot be on the same cell at the end of the move. And it is finally given that any officer who is not able to make a move gets eliminated. Okay, so you can read these instructions for the moves that are allowed to make for the officers. In the similar way, chef can also make some move. That is, once officer are done making their move, chef will also make a move in the similar manner. That is, he will try to move to an adjacent cell which is not occupied. Okay, that is very important. And if chef is not able to make a move, then he also gets eliminated. So that is the case. Finally, it is given that if all the officers are eliminated, then chef runs away. So what is our task in the question? We need to find the maximum number of officers that can be eliminated by chef, and whether chef can run away or not. So the first part is finding the maximum number of officers that will be eliminated by chef, and the second part is whether chef can run or not. So the second part actually depends on the first part. Why? Because if all the officers can be eliminated, then chef can run away, or else chef cannot run away. So that is the question. We can see some examples to understand it better. So in the first example, you can see that there are total two police officers standing on position 1 and 4. So we have positions, let's say 1, 2, 3, 4. Chef is standing over here. Okay, chef is on position 2, and police officer 1 is on position 1, and police officer 2 is on position 4. So in this case, uh, the answer comes out to be that chef can eliminate at max one police officer, and he is not able to run away. So how he can eliminate this one officer? Actually, the order in which the moves are done and the moves which are actually be going to be done with by the officers, there are many such possibilities. So we need to actually find out some solution that works for any given case. Okay, not just this particular case. That how can we comment that exactly or at max one police officer is going to be eliminated? For that, we need to actually see the solution approach. But the input format is going to be as follows. You will be given the number of police officers, that is 2, the initial position of chef, and after that, the positions of the individual officers. So you can see over here that there are total 2 test cases, but the first one is as follows that we just saw. Now, let's see how to solve this problem in the solution approach. So, the solution approach goes as follows. We are going to first solve the question for the case where all the officers are present towards the right of chef. That is, chef is present somewhere over here and the officers are present towards the right. That is P1, P2, P3 and so on. You might be wondering why only the case where the officers are present on the right, because the other case where the officers are present on the left is going to be quite symmetrical to this one. So first let's try and solve the question for this case. So in this case, what happens is that there will be two cases. That is, the in one case, case 1, the parity of chef's position and uh, officer 1's position is same. That is, either both of them are odd, okay, or both of them are even. That is same parity, okay. And in the other case, opposite parity. That is, if one of them is odd, another one has even position and vice versa. These are the two cases. Now let's analyze these two cases in detail, because these are the only two possible cases. Either chef and P1 can have same parity in the beginning or they can have opposite parity in the beginning. So let's analyze these cases in detail. So what happens in case 1? So we have case 1 as follows. Let me just write. So we have case 1, same parity. Okay. So what is going to happen in this case? In this case, we have chef present at position C and officer 1 at position P1. So either both of them are going to be at odd positions or both of them are going to be at even positions. And remember, in the question, it was given that initially all the positions are distinct. Okay, so they cannot be at same position. Okay, but the nature of their position can be same. That is, either they can both be odd or both be even. So in this case, there is one interesting conclusion that you can reach to, and that conclusion is that officer P1 can never get eliminated. Okay, now you might wonder why we can directly say that. So the reason behind that is that, let's understand that using some numbers. So let's say chef is present at position 3, okay, and then police officer is present at some odd position. Let's say the closest one. So it can be 5, right? It can also be 7, 9, anything, but let's consider 5 for now. So in any move, because first the officers move, what we can do in each move, the officer P1 will always move one step left. So from 5 he will come to 4. Now definitely, because chef cannot go to 4, he will try and move to the left, right? Because he has to go to an adjacent cell, or else if he cannot make a move, he will get caught. So he will try to run away. So the same will keep on happening, and it cannot keep happening forever. Why? Because remember that our grid has some finite limits. It ends at here minus 10 to the power 10, and on the right hand side to 10 to the power 10. So in each step, what will happen? Police officer 1 will do one left move, and again to run away from that officer, chef will also make a left move. It will keep on happening all the way up to the leftmost point of our grid. And then what happens? Chef cannot run anymore and chef will get caught. So P1 never gets eliminated. And because P1 never gets eliminated, all the officers present to the right of P1, that is P2, P3, P4, they also never get eliminated. Why? Because the moves that P1 is making is forcing chef to run away. So they are not affecting the other officers in any way. Also, it also ensures that they always have a place to move because P1 is moving one step left. So there is one vacancy created over here. So P2 can also move one step left, P3 can also move one step left, and so on. So there are the vacancies created in the subsequent moves. Okay. So that also ensures that they are not getting eliminated within themselves because they are not having space to move. Always there is a space to move. And in the end, chef gets caught. So case 1 is done. That is what happens if they are of the same parity. That is C and P1 are of same parity. What happens? The officers from P1 and towards the right of P1, they are never eliminated and chef gets eliminated in this case. Why? Because in the end he'll be caught up. Let's see the other case now. The other case was that what if they have opposite parity? Opposite parity. So again, for this case, we'll take some numbers, for example. So let's say chef is present at index 2 and the officer P1 is present at index, let's say 7. Okay. So in this case, what can chef do? This case also leads to an interesting conclusion that officer P1 will always get eliminated. Okay. We can't comment about the other officers, but the officer P1 will always get eliminated. How? The set of moves can be as follows. In every move, irrespective of the move that the police officer is making, chef will move one step right. So chef will go from 2 to 3. Okay. And because their parity is different, what will happen? If they make the same move, that is if police officer had also made the move from initial position to the one step right, so their distance will remain the same. uh, Officer went from 7 to 8 and chef went from 2 to 3, so their distance remained the same. And if they make opposite move, the distance get reduced. So of course police officer doesn't want to be eliminated, so he will try to what he'll try to go towards right as much as possible. Okay. uh, But before going towards right, there may arise a case such that instead of going towards right, what if he goes towards left? So he went from 7 to 6. Okay. Chef went from 2 to 3. Again from 3 he went to 4. Police officer went to 5. So here we have chef is over here, officer is over here. Now, definitely if he wants to survive, police officer, he has to make a right move now. So after this configuration, that is C is present at 4 and P1 is present at 5. Now both of them start moving towards right. That is P1 will go from 5 to 6, then C will go from 4 to 5. So chef is running behind the officer 1. And again, this cannot go on forever. Again, why? Because we have a limited grade from minus 10 to the power 10 to 10 to the power 10. So if there comes a point where P1 cannot move any more towards right and C is towards his left, so what will happen? P1 will for sure get eliminated, right? Because he cannot make a further move. He cannot go towards right and he cannot go towards left because chef has occupied the cell to the left. So in this case of opposite parity, you can see that for sure P1 always gets eliminated. So with these cases, we have determined what happens to the officers that are closest to the chef. Okay, that is the officer P1. But what about the other officers? So for example, in this case, case 2, what after P1 is eliminated? Now comes P2. Now again, because P1 is eliminated from the grid, you can again consider there are two cases, right? Depending on the initial, sorry, not the initial, the current coordinates or coordinates of these two, that is C and P2, again depending on the parity you can decide whether P2 will get eliminated or not. If they have opposite parities, they will get eliminated, that is P2 will get eliminated. If not, P2 will survive, and along with P2 all those presents towards the right of P2 will also survive. So I think now you might have understood that how we are going to frame our total solution. Okay, so the total solution, that is the full solution, is going to look something like this. It is not that always the officers will be present towards the right. The chef can be present in middle also. So let's say C is present over here, somewhere over here. Then there are some police officers over here, and again there are some police officers towards the right. So I will tell you one case, the other one is just the vice versa. Okay. So let's say that the parity of the chef's position was odd. Okay. So we just now saw that this officer, officer P1, that is closest to chef, his parity determines whether he will be executed or not. That is sorry, whether he will be eliminated or not. So if he has the parity odd, then all these people are saved. Okay, that is they are never going to be eliminated. But what if this guy as an parity even, it means that he is going to be eliminated. Then we go to the next guy. If he also has the parity even, he will also get eliminated, and so on until we get the same parity as chef. So if we get the same parity over here, then all these are not eliminated. Okay. Also, similar, whatever is the story for the right hand side, symmetrically you can apply it for the left hand side. If here the parity is even, then this guy will also get eliminated. Even, eliminated, even, eliminated. If here it becomes odd, then that is same as chef. So this guy will be not eliminated, and all the guys towards the left of this police officer will not be eliminated. So there you have it. There is the solution. So definitely for applying this, all these positions of officers, okay, they should be in sorted manner. Why? Because we are imagining them on the given grid, right? So we'll position them on the grid, and then we will find the first officer towards the right of chef such that it has same parity as chef. So here you can see that these two have the same parity. So, and similarly, on the left hand side, we will find the first police officers towards the left such that the parity is same. So that is over here. And once you have found these, you know that how many police officers are going to be eliminated. That is, these three are going to be eliminated over here, and these two are going to be eliminated. And then using these counts, you can easily answer the questions asked. So the implementation for this problem goes as follows. So in the implementation, you can see that first we take the input for number of test cases. Then for each test case, I take the input for number of officers and the initial position of chef. Then I create an vector and take all the input positions for officers, sort them because we need them in a sorted manner. And then after that, I have two counters, capital L and capital R. So what these two variables are going to denote, that is very important. Capital L is going to denote the number of officers that are not getting eliminated. Similarly, R is going to denote the number of officers that are not going to get eliminated. But why two variables then? L is for the officers that are present towards the left of chef, and R is for officers that are present towards the right of chef. So for the officers present towards the left of chef, I find the rightmost. Okay, so in this diagram, you can actually see that these are the officers, these yellow ones are the officers present towards the left of chef. But amongst these this officer is the one that is having the highest index. Okay, so this has, let's say, index 0, index 1, and so on. So this has the highest index as well as the parity is same. Okay, that's what we are doing in the code. We are running from 0 to n. If pi is less than c, it means that it is present to the left, and if the parity is same, I update the value of L as I plus 1. Now why I plus 1? Because the indexing is 0 based, but we are actually counting the officers. So for that I am doing I plus 1, because if I is 0 and if the parity is same, it means that at least that person is going to get saved. So the count has to be 1 and not 0. That is why I plus 1. And else we are breaking. Why else we are breaking? Because if pi is not less than c, it means that we have finished checking for all the officers that are present towards the left. So that is done. So we break the loop. So this loop is for the officers present toward the left, and this loop is for the officers present towards the right. And in the end of both these for loops, we have in the variables L and R number of officers that are going to get saved. Okay, so pictorially let me depict it, how it is going to look. If these are the initial positions, P, there are many P's, then there is a C, and then again there are many P's. Then L is going to be this, the count of prefix of officers that are going to get saved. R is going to be this, count of prefix of officers that are going to get saved. Other ones are definitely getting eliminated. Okay, these are getting eliminated. So these are the counts that I am having. So what does this mean? This means that if C is odd, this guy also has to be odd. If C is odd, this guy has to be on odd position. And similarly for even, all of them have to be even. So that is what we are finding out in the code. And once we have that, we can easily find how many total officers are getting eliminated. How? From the total n, you subtract L plus R. So if you subtract L plus R from n, you get the number that is getting eliminated. So you output that first, and after that you have to say whether chef is able to run away or not. How to check that? If all the officers are getting eliminated, it means that officers getting saved are 0. So if L plus R is 0, then chef is able to run away. So we output 1, or else we output minus 1. So this completes our implementation in C++. Now let's submit the code on CodeChef ID to get the verdict. So I can just paste the code. I'll just change the language and submit the code, and now wait for the AC verdict. Great. So our solution works. I hope you guys understood the problem as well as the explanation. If you have any doubts, you can ask them in the comments below. I'll try to answer as much as I can.